Alright, so this is our next notes in geometry, and the next thing we're going to be looking at is right triangles. And the first subject we're going to touch on are geometric mean, or geometric means. And a basic definition for this is it's positive square root of two given numbers when multiplied. And let me just give you a quick example, and then I'll show you actually two examples, and then we'll actually show you how it applies to triangles as well. Okay, so example one, so geometric mean of two numbers, a is 6, b is 6. So then we could write them a over x equals x over b, and then we would cross multiply. But really in the end we end up with x equals the square root of ab. So we just, do the cross multiplying, we get x squared equals ab, and then we want to do x equals the square root of ab. And this is our equation we're going to use for geometric means. Okay, then when we solve it out, and sometimes we'll have this perfect answer, sometimes we won't. Okay, but we solve it out, so x equals the square root of ab, x equals the square root of 6 times 6, x equals the square root of 36, and x just equals 6. That's a pretty easy one. It doesn't have to be that way though. It could come out a little more complicated. Let me show you a more complicated one here. So geometric mean between 8 and 10. Okay, so then we just put in x, and we got a and b. There's a and b. 8 times 10, square root of that. We can see 80, it's not going to be a perfect square, so I'm going to kind of mess around with it a little bit to get it a little more, maybe not decimal, but we can pull a square root out of it so we can get a simpler answer. So here we have 8 times 10, but then we can write out 8 as 4 times 2, and then we can write out 10 as 2 times 5, and we're looking for perfect squares here. 4 is a nice perfect square. We're going to pull that out, it's going to become 2. So it's going to be 2. And then this 2 times 2 is 4. These are going to get pulled out, and they're going to be another 2. So then we're going to have 2 times 2 pulled out. It's going to give us 4. The only one left is 5, so we have 4 square root of 5. And that would be a good enough answer. You don't necessarily have to do decimals on that. So that's kind of the geometric mean. Let's see though how we can use it in with triangles. So the one thing we're going to do first of all is use altitudes. And altitude is just a line that runs from the vertices of one. It runs to the cross, whether it's a hypotenuse, a leg, or whatever. Here on right triangles, we're going to run it across to the hypotenuse. Okay, and there's some special rules that can help us understand things when we form an altitude between one vertices and the hypotenuse. Okay, in the right triangles. So it says if an altitude is drawn to the hypotenuse, then if we do that, okay, the new triangles are similar. An original triangle is similar to the two new triangles. So let me show you how that kind of works. So let's say we have this original triangle FGH, and we draw this altitude from G through the vertices over to the hypotenuse side FH, and we do an altitude so it's at a right angle. That then tells us we have some new triangles now. So we have FJG right here, and then we have GJH, which is right here. And we try to match up these sides, make sure the sides that we're comparing are the same or the similar sides. So then this law, this altitudes and right triangle, says that these are similar, but it also says the original triangle FGH is also similar. We could write this out by saying triangle FJG is similar to triangle GJH is similar to triangle FGH. So it's kind of cool. You start out with a right triangle. If you draw from one vertices across to the altitude, you make it a right angle. Instead of having one triangle, you now have 3 triangles that are similar. Okay, so that's geometric. That's kind of altitudes and right triangles. Let's see how we can use this though with a geometric mean. Okay, so there are really 2 theorems we're going to look at, and the first one is the altitude theorem. Okay, and this says when an altitude is drawn to the hypotenuse of a right triangle, then the hypotenuse is 2 segments. So here we have the vertices B. We draw across here. We have 2 segments, X and Y. Okay. And that also we can then figure out that these 2 segments, X and Y, when we add them together, they're equal to the geometric mean. And also here, if we call this altitude H, that is also equal to the geometric mean. So we could figure out the geometric mean between X and Y, and that should be equal to the length of the altitude. That's the geometric mean altitude theorem. We then have the geometric mean leg theorem. This one's a little bit harder. This says when an altitude is drawn, just like we did with this one, we have it right here, okay, is drawn to the hypotenuse of a right triangle, then the hypotenuse is two segments, and we call them x and y here, okay, and then it tells us also that the leg length, so we have the original triangle, ACB we'll call it, it has legs, right, the hypotenuse is right here on the bottom, between, let me fix this, between A and B, that's the hypotenuse, right, this whole thing, C, okay, the whole thing. And then we have leg A, and we have leg B, right? And this is like A squared plus B squared plus C squared, right? So here we know then that this leg length, A, is equal to the geometric mean between the hypotenuse and segment adjacent to that leg. So we have A, that will be equal to Y, and then the old hypotenuse of the original triangle. So if we do the geometric mean, square root of Y, one attached to it, in the old hypotenuse of the triangle, if we do the geometric mean, that should be equal to what the length of A is. We can go the other way. This is the other leg of the original triangle. We can say it's equal to the geometric mean, the leg attached to it, x, plus also the original hypotenuse of the original triangle, C. Okay. So these are really useful. It can help us figure out, well, is a triangle actually a right triangle? Maybe it doesn't say that it is, and we can plug in an altitude and see if this leg theorem works or the altitude theorem works, and use geometric mean to help us do that. Okay, so that's kind of the initial notes. Let me know if you have any questions. Add these to your notebook, and then we'll do some practice ones in class. And good to see you after we've been gone for a week.